Hi, I'm Alex Popham. I'm the 4-H agent in Breckinridge County. Here at the Extension Office, we are part of the Cooperative Extension Service at the University of Kentucky as part of the College of Ag, Food, and Environment. Today I'll be sharing lots of information so that if there are any 4-H members or youth out there that would like to make their own geology collection for 4-H festival, for the county fair, or qualifying for the state fair, hopefully this will give them enough information that they can get a good start on it. And I am going to be referencing lots of materials that can be found on the Kentucky 4-H website if you click on the Geology tab, including this 4-H Geology Project book. And there's also great resources on the Geology Department website as well as the U.S. Geological Survey website. So even though our geology projects in 4-H can include rocks, minerals, and fossils, and you'll see all that good information in that 4-H project book, we're just going to be focusing on minerals today because they have some really cool characteristics to help identify them. So I have a lot of minerals out here, and we're going to walk through all their unique characteristics and how to identify them. And then we'll end by actually looking at how to assemble a geological project for the 4-H program. So let's start with the first category, the first characteristic that most people think of when they see a mineral, and that's the color that they appear with the naked eye. So it's pretty neat. On our planet, we have lots of variety, a lot of diversity in the color and types of minerals that are found on our planet. I'm just going to point out a few. Most people are familiar with fool's gold or pyrite. That's this beautiful gold color. A lot of people are familiar with that bright yellow sulfur that has that rotten egg smell. Very beautiful mineral. Over here we have some beautiful green fluorite, as well as some rose-colored quartz. So lots of diversity just in the two boxes that we have here at the Extension Office. The next characteristic that you can use to identify a mineral is cleavage, or how a mineral breaks apart or fractures. I have two examples of some common minerals that have two different ways of cleaving. The first is mica, and you can see that it peels off or cleaves off in these nice horizontal thin paper-like layers. Very characteristic of mica. On the other hand, we have calcite here, which cleaves in three directions. So it cleaves this way, it cleaves this way, and then also cleaves in this direction. So three different axes that it will cleave upon. And a good way to tell that is instead of being 90-degree angles when it cleaves off, it's more of a rhombus shape, which you can see from the top. So three different directions of cleavage here compared to the one with the mica. The next characteristic is the streak color. If you take a mineral and you scratch it on a piece of tile, often the minerals will leave behind different colored streaks, and those can be characteristics of a particular mineral. So we'll just start out with some apatite. It's a beautiful blue color. You might think that it would leave a blue streak behind, but actually when you scratch it, you end up with white streaks. If we grab our green fluorite, again, you might expect that it's going to leave a green color behind, but it actually leaves more white lines. Our corundum, kind of a brown, reddish tint to it, also leaves a white streak. If we move on to our lodestone, we ended up with a dark brown, almost black color streak. Very characteristic of lodestone. And then finally our pyrite is going to leave a dark black line that has a little bit of a green tint to it. If you can see it well on the video. Okay. The next characteristic we're going to look at was developed by a German geologist, Dr. Ohms, and he compared the hardness of minerals to common items that you could find around your home, and he created a scale with one being the softest mineral, and our example here today is talc. It has a hardness scale of 1 versus a diamond that would be on the other end of the scale. So we're going to compare these very quickly, the examples I have here, to some common items that you can find, first being our fingernail. So even my short fingernails, I'm able to actually leave scratches on that talc. It's a very soft mineral. So again, we're going to give it, on the ohm scale, a hardness of 1. If we move over to this gypsum, on the hardness scale, it's only a 2, and that's because we can take a penny and leave marks or scratches in it. Now, I can't scratch it with my fingernail, but I can scratch it with the penny. Next, we have fluorite, that green mineral I mentioned before, and I can't scratch it with the penny, but I can definitely leave some marks in the penny. It's much harder than that penny. And that's because on the scale, this particular mineral is a 4. Next we have some feldspar, and this one's pretty cool. It has a hardness of 6 and can actually scratch glass. You know, we could have taken glass and scratched all the other minerals we've seen so far, but this guy can't be hurt by glass. It's actually gonna scratch glass itself. Sorry, that's like fingernails on a chalkboard, isn't it? But I'm leaving some deep scratches in that glass with this feldspar. And again, that's because it's a hardness of 6. And then the last thing you can test with is stainless steel, which I'm using a knife today. Please do not do that at home. Find something else that is stainless steel that you can test with, or make sure you have parental guidance as you're doing this. But I have some topaz, which is pretty high on the hardness scale. It's an 8. And I can actually scratch this stainless steel knife. Okay, I could take stainless steel and leave scratches and all the other minerals, but the stainless steel won't damage the topaz. The topaz will actually scratch that stainless steel. The next characteristic you can use to identify minerals is an acid test. I just have some cold vinegar here with some calcite, and you might need a hand lens or a magnifying glass, but any of our minerals that have carbonate or something that's going to react with a weak acid like vinegar, you'll see bubbling under that hand lens, and that's the carbon dioxide being released. So I'm going to put a little bit of the vinegar on there, and if we were to zoom in with our hand lens, you could see the fizzing and bubbling as that carbon dioxide's being released. And then finally, the last characteristic is magnetism. There are some minerals that are deep-rooted in our American culture, like lodestone, where they were used to, used in compasses. Our Native American cultures use this mineral in a variety of ways. It's a pretty cool mineral rich in history, but it's also magnetic. So you can take a magnet and test out your minerals. And if it sticks, you might have lodestone. So these are a few examples of the different characteristics you'll want to look out for as you're identifying your minerals. And again, there's great resources online on the 4-H website and the Geology Department website. And once you have collected your minerals, or there is the option to buy them, so they can be store-bought or collected, then you're going to identify them and then start to assemble your box. So this is a standard size for a wooden geology box, okay? And it has a plexiglass cover. Now inside, typically you would cover the entire bottom with fabric, but this particular insert came out of a different size box, so that's why the fabric isn't covering the entire bottom of the box. But you would cover it with fabric. You would glue your specimens, your minerals, rocks, or fossils in place, and then you'll attach your labels, and these labels are available on the website. So you'll see on the labels, you'll note the common name, hardness, chemical formula, which you can research online. You'll note if it's purchased or a gift or found, and then where you bought it or found it. And then the great thing about this project is not only are you learning to identify the minerals, but also what uses they have in our lives today. So for instance, talc is used in paper, paint, soap, and even pottery still to this day. So lots of great ways to learn about the history of these minerals, rocks, and fossils, as well as how to put together this cool display for the fair or your local festivals. So I hope you've enjoyed it. I hope you get out there and get hunting for some cool fossils, rocks, and minerals that you can include in your own collections. If you have any questions, feel free to contact your extension office. Have a good day.